Hello, I'm the power guy from TDK-Lambda. If you are looking for a non-isolated DC-DC PCB mount converter for a new program, you can use a power chip and use that as a basis for your design. Alternatively, you can purchase an off-the-shelf solution from a power supply manufacturer like TDK-Lambda's i7A. In this video, I am going to discuss the advantages and disadvantages of both methods for a 500-watt DC-DC converter example. There are a number of things to consider before deciding which path to take. The available board space and the number of external components required. Thermal design. Development cost and time. The expertise to embed such a device on the board. Testing and certification. Future-proofing. Inevitably, there will need to be external components. The question is, just how many? Using the i7A solution, the majority of components are included in the module. There may be two small ceramic capacitors for noise reduction and electrolytic capacitors, depending on the input or output load impedance. With a power chip, more external components are required for operation. These extra components consume board space and cost money to buy and mount. Every power supply generates heat, and the converter will need to be cooled. Cooling a power chip requires conduction cooling to either the PCB via the pins or an external heatsink. Also, be aware that the heatsink will also have to accommodate the height difference between the power chip and the external inductor, further complicating the heatsink design. The thermal resistance is often too high for convection cooling. Off-the-shelf solutions are often available with multiple cooling options for convection, conduction, or forced air. Off-the-shelf solutions require minimal development effort and knowledge to implement. It is also very likely that an off-the-shelf solution will have the control loop already optimized to compensate for load changes, avoiding output oscillation. This reduces the risk of printed circuit board changes and a delayed launch schedule, keeping development costs low. Power supply manufacturers have highly automated test equipment. Thus, the off-the-shelf solution will have already undergone extensive testing. This will include monitoring output voltage variations over its full input voltage range, from 0 to full load and from minimum to maximum ambient temperatures. Ceramic capacitor values can significantly vary with temperature and also the applied voltage. Large batch sizes are tested to account for component tolerances, including life testing with thermal shock. Off-the-shelf DC-DC converters will often cover multiple power levels and input voltages. In the event your customer requires a 48-volt input rather than 24-volt, a solution can be quickly and easily implemented. If power requirements change, some manufacturers have standardized footprints covering multiple series. There is no change to the PCB and minimal component changes and testing is needed. If a power IC is being used, a different product type would most likely be needed, with a new PCB layout and alternate external components. This would require additional development costs and more extensive testing. To summarize, both a power IC and off-the-shelf solution have their benefits. Make sure you consider not just the products or components, as your decision, chip or solution will affect the entire project cost and scope. Knowledge is power. Power is TDK-Lambda. Thank you.